The easiest way to see the new asynchronous mechanism at work is to create a small program that uses the asynchronous mechanism while keeping the UI alive. Our user interface will consist of a button and a text block inside a stack panel. The button simply says click me and has a click event handler, and we're going to use that to show that the user interface is alive. The text block will be used to display the content of the calculations that we'll be making that will substitute for a lengthy process and that we will want to run asynchronously. Let's take a look at the button click handler first. Here all we're going to do is show a message box that says that the button was clicked. The real work is going to be done in an asynchronous method that we can call compute stuff async. Let's go ahead and write that method. The first thing to know about that method is that it needs the keyword async because it's going to run asynchronously and because we will be using the await keyword with it. It will not return any value, so we'll use void, which is one of the legal return values for an async method. Our method is going to have a forever loop so that it runs continuously. And inside the forever loop, we're going to start by creating a local variable sum and initializing it to 0. And we're going to set the text of our message text block to the word computing. Here we would call out to a method that would run asynchronously and do a great deal of work. What we will do instead to substitute for that method that might be talking to the network or to the disk is we will use a anonymous delegate using a lambda expression to just run a task that will sum 200 million square roots. You have to keep a computer pretty busy to be able to detect that something lengthy is going on in the background. We start with the await keyword because we want to wait for this to finish before we do anything else. And then we're going to put the lambda expression inside the run. So we'll scroll up and you can see, if I make a little bit more room, that what we're doing here is we're calling this delegate, and it is doing a for loop for int I equal 1, I is less than 200 million, sum plus equal the square root of I. When that completes, and only when that completes, we will update the message box's text to give us the current sum. Once we've displayed the sum, we're going to call our method again and do the lengthy process one more time. And then we will display the sum again. Let's do that a total of 4 times. So we'll copy the 2 we have and we'll drop them in again. Because that's in a forever loop, that will continue to run again and again. Normally that would block the UI while this work is being done. But because we have marked this async, we'll be able to use the UI even while this computation is happening. Further, because we've used the await keyword, we don't have to have a callback at the end of this run. We can just await for it, and then when it's finished, it will pick up on the next line, and then await for this work to be done, and it will be picked up on the next line, and so forth. Let's run the application, and you can see that it is beginning to do its work, and there it is doing the work in the background, adding those 200 million square root sums, and you would expect that the button would be frozen during that time, but sure enough, the button is working properly. The UI thread is free because this is being done asynchronously, and yet there are no callbacks, no spaghetti code. It's very straightforward to do.